Hello, welcome back to Algebra. We're working on the conjugate root theorem. We're basically doing problems that are very similar to what we've done in the last lesson. We're just increasing the complexity. So, the concept is the same. If you know that one root of a polynomial is some complex number, 1 plus 2i, the conjugate root theorem tells you that you automatically know that another root is 1 minus 2i. That's a conjugate. They always come in pairs like that with polynomials that have real coefficients, which is every polynomial that we encounter in this class. So these problems are going to be more complex, but only because the math and the simplification becomes hairy sometimes, not because the concept is hard. But that's okay. I want to do some difficult problems with you to show you how you roll your sleeves up and really crank through it whenever it becomes lengthy. So what we have is the following. We want to solve the equation given. We want to solve this equation. And the equation I'm giving you is x cubed plus x minus 10 is equal to 0. And you're also given that a root of this equation is equal to negative 1 plus 2i. So you're basically told to solve the equation. So you look at this polynomial. It's a cubic polynomial. From the other theorem that we've learned before, we know that there's got to be three answers, three roots to this. But we're also told one of the roots here. So we know that there's going to be two more roots total for a total of 3. We have to have 3. It can be a mixture of real and complex roots, but we know we have 3. We're also given one of these complex roots. So from the conjugate root theorem, we also know that another root, we don't even have to prove it. We know that another root exists, and that's going to be the conjugate of this one, negative 1 minus 2i. So because of the conjugate root theorem, I know this is a root, and I also know that this is a root. That's only 2 roots, however, and that's a cubic polynomial on the board, so there has to be one more for a total of 3. How do you find a third root? The problem just says solve the equation. What they want to know is what values of x make this thing go to 0. We already know 2 of the values. X is equal to negative 1 plus 2i. That's 1. You stick it in here, it'll go to 0. If you plug in negative 1 minus 2i, you plug that in. That's also going to make it go to 0. But we know that there has to be a third root out there. Furthermore, that third root that's out there, we know it has to be real. How do we know that it has to be a real number and not an imaginary number? Because imaginary roots always come in pairs. So if the third one were imaginary, then it would also have to have a partner, and that would be 4 roots, and that's too many. So we know that it has to be 1 real root, which we don't know, and 2 complex roots, which we do know. Question is, how do we find that other unknown root? And so here what we have to do is, it's one of those things where once I show you how to do it, it becomes obvious, but you don't really think to do this the first time you see a problem like this. We know that this is a root of the equation. So we then know, if I'm going to write the factored form of this equation, that we know a factor that comes from this root and another factor that comes from this root. And so the first factor can be written as x minus 1 plus 2i. This is one factor. And then another factor is this one, x minus negative 1 minus 2i. Now, why am I writing it in this weird way? Well, because if I set this thing equal to 0, I know that there's some other factor here I don't know yet. But this factor, if I were to set this thing equal to 0, grab this imaginary number and add it, because it's added here, goes to the other side. If I were to set it equal to 0 and solve, then I would get back to this root. If I set this one equal to 0, then I would add and get this back as a root. So I know that this is the right way to write it. The roots that come from, the factors that come from roots are of the form x minus the root, x minus the root. Now the thing is, this is a root, but we know that there has to be a third root. I have no idea what it is, so I'm going to call it q of x. Don't get scared by this. It just means there's some other parentheses term that has x that is another root of this equation. Okay, and we're saying that this is the factored form of the polynomial that we're given, x cubed plus x minus 10. I mean, think about what it means to factor something. We factored quadratics all the time. What you're saying is that the original thing you have can be written as the product of those factors. We're saying that this cubic can be written as the product of 3 factors. This is a factor, this is a factor. These factors give us the roots we know about. And then there's some other factor here. There's going to be another parenthesis here. I'm labeling it q of x, but what it means is it could be like x minus 4. That would mean the root would be positive 4. Or it could be x minus 6. That would mean that that third root is positive 6. Or it might be x plus 2. That would mean if you move it over that the root would be minus 2. I have no idea what this is. That's what I'm trying to find, so I just label it something.